Hey everyone, welcome to the Audrow Nash podcast. Today we're diving into the world of robotics and manufacturing with Saman Farid, the founder and CEO of Formic. Ever wonder how robots could revolutionize American factories? Saman and his team are tackling this head on, making robotic automation accessible to small and medium-sized manufacturers across the United States. They're not just selling robots, they're providing fully managed solutions that are transforming how factories operate. In this episode, we'll explore how Formic is using cutting-edge AI to streamline robot deployment, why focusing on uptime and utilization is critical for success, the challenges facing American manufacturing and how robotics can help. If you're interested in robotics, AI, or the future of American manufacturing, you're in for a treat. Let's jump in. Hey, Saman, would you introduce yourself?
Sure. My name is Saman Farid. I'm the CEO of Formic. Prior to Formic, I built and sold two software companies and then was a VC for about 10 years where I was investing in a lot of robotics and AI,
hmm
and saw a lot of challenges with the way that people are building robotics technologies and trying to get them into market. So started Formic to really accelerate the event of the robot revolution.
Hell yeah, love it. So tell me a bit about Formic, the general details of it. How many people, when were you founded, round of funding that you guys are at, these kinds of things.
Yeah, so we started Formic about 3.5 years ago. We've raised total about $60 million over 3 rounds. And we have about 60 employees right now. We are deploying robots in a variety of different types of environments. We are currently already deployed in about 100 manufacturing facilities across the US, and we're continuing to scale that business very quickly.
That's awesome. Yeah, it's so exciting. You guys are in the scaling phase right now. So tell me about Formic. Tell me, what do you guys do? What problems are you solving? How does your system work?
Yeah, so what we do at Formic is we try really hard to improve the accessibility of robotics and automation for manufacturing facilities. What that means is we drive down all of the peripheral costs related to deploying a robot by automating them with AI. So that means automating the site evaluation process, automating the configuration and deployment process, operating all of the kind of post-deployment service and maintenance processes, so that we can provide full end-to-end drop-in robots that customers pay for by the hour. And what that allows them to do
Hmm.
is not have to become robot experts themselves. A lot of our customers can show up and just quickly access the best possible robots for as long as they need, whether that's 1 month or 10 years. And we can solve a bunch of their problems very quickly. So, kind of in a more practical sense, we are able to use technology to drive down the cost and improve the speed of deploying robots by about 7 to 10x.
Wow.
And we're able to turn that into kind of
How do you,
instant operational deployment speed. Yeah,
how do you benchmark that? Like how do you get 7 to 10x? And that's bonkers big. So 700 to 1,000%
that's right.
improvement.
Yeah, yeah. There's a lot of stats around it, but for kind of currently in the United States, for a typical robot deployment, um, the timeline from kind of decide to do a robot deployment to actually see the system installed is typically on the order of magnitude of 4 to 6 months,
hmm
given all of the steps involved related to that kind of site preparation, system installation, procuring all the parts and components, programming, things like that. So we are typically doing that in about 2 weeks. So that's kind of a
That's
massive
awesome.
savings on kind of deployment speed. In terms of costs, it's there's a lot more kind of fluctuation depending on the type of system. So the
Of
benchmark
course.
that we use is similar systems, and we're able to as you're I'm sure familiar, for typical robot deployment in the U.S., 60 to 70% of the cost involved is in custom engineering services. That custom
Definitely.
engineering can be anything, right? It can be figuring out what the thickness of the concrete is that needs to go, beneath the system. It could be configuring end of arm tooling. It could be designing all the safety configurations and interlocks and safety fencing and where the safety scanners need to be. And all of them are site specific. So these are not things that you could say, oh, I have an AI powered robot that's much smarter, so I don't need that anymore. Right? Like all of those things, regardless, need to happen. And so uh, we are able to reduce that portion of the deployment to near zero because we've automated most of it. Not by kind of making the robot more intelligent, but by kind of focusing on those specific processes where there's a lot of time and energy that needs to go into robot deployment. So those are the kind of the two axes that we think about. Uh,
Mm-hmm.
the third one is kind of total cost of ownership of a robot. Um, so the kind of initial upfront deployment cost of a robot is typically, only one portion of your if you're a factory and you want to deploy robots, the upfront cost is one portion. The really big cost is actually the ongoing service and support, right? Your needs change, your programming needs to change, your configuration, hardware configuration needs to change, your safety configuration needs to change, and then robots wear and tear is kind of natural, right? And as all those things start to happen, there's a huge cost that's typically incurred on the order of magnitude of 10 to 15% of the cost of the system per year to keep that system up and running in a kind of performative state. And that's one
Mm-hmm.
of the areas where all the software and tooling and kind of operational excellence that we've built drives that down significantly as well.
Mm-hmm. That's really cool. How do you expect, so when you were saying like safety related things might change, what does that mean? Like why would safety things change during the course of operating? Is it just like new standards, they're doing new processes, or why are some of these things changing, I
Yeah.
suppose?
So like I'll give you a very simple example, right? If you are just picking up boxes, if you're picking up a 10-pound box over and over and over again, there's a certain kind of safety regime associated with that. If you're picking up a 40-pound box or a 60-pound box or 80-pound box, uh, just that, even if it's the exact same operation and the exact same movement, the safety constraints associated with that suddenly change a lot. Right?
Mm,
Because if that box drops when, let's say, the kind of compressed air stops coming to that system, the system loses vacuum and that box drops, the damage that's caused by 40-pound box or 10-pound box are very different. So that's a
mm-hmm,
very trivial and small example, but the production needs in a manufacturing facility are not static, right? There's always things that come up, and as those configurations need to develop, you need to readjust, you need to recalculate all of your safe distance calculations. You need to figure out what happens if somebody enters the cell prematurely. Does the robot go into emergency stop, or does it slow down? How does it slow down? What are the things that
mm-hmm,
it's interlocked to? What are the safety scanners that you need to have in order to support that? Like there's all these things that need to be addressed. Um,
mm-hmm.
and yeah, like the maximum speed that robot can operate will be different. Like let's just say you're stacking that box into a pallet configuration, the maximum height that you're able to reach will have to change. So there's all these things that are just fundamental physics related things that you have to address. And
Mm-hmm.
um, I think that there's a lot of optimism around kind of AI powered smart robots that will solve all of that for you. Unfortunately, like that's not really the case, right? I think uh, the AI on the robot will make it easier and easier and easier to program the robot to do that task. But at
Mm-hmm.
the end of the day, there's still all of these other considerations that go beyond can I make robot move from A to B. There's all these other considerations that need to be taken into account. And
Mm-hmm.
what we've found is that there's not a lot of emphasis being placed on those things right now.
Yeah. And so that sounds really cool. Um, Before we get into all of the really cool things you guys are doing regarding configuration, just to make the whole thing a bit more tangible, Do you want to tell me some case studies that show kind of the diverse sets of problems that you guys are helping to solve?
Yeah, so we're deployed right now in like I mentioned earlier, about 100 plus manufacturing facilities. So um, uh, one of the things I'm very proud of is about 70% of those customers never had robots before Formic.
That's
And
sick.
that's,
Hell yeah.
yeah, like I think we're really trying to increase
I'm impressed by that
accessibility.
30% too.
Yeah, there
Like
are definitely some that
that's
have.
nice.
Well, it's the story of that 30% is actually a little bit more sad than the 70% because typically the ones that have had robots in the past actually
It's been
have,
a bummer.
yeah, they have a robot graveyard, in the corner somewhere. That's a source of embarrassment because they've deployed some robots, some, halfway through they didn't work or they spent a bunch of money on them and they ended up getting stuck with something that didn't work. So there were very few that have kind of high functioning robots when we
Hmm.
arrived. But that's representative of kind of all of US manufacturing. And 90% of American factories don't have even a single robot. So uh, we
It's
have,
wild.
yeah, I mean, it's unbelievable. And I think the main thing is also it's untenable, right? I think for America to
Uh-huh.
have a manufacturing base that sustains through the 21st century and is competitive. We are drastically kind of undertooled, right? These manufacturers are
100%.
stuck with um, really really high labor costs, really low overall utilization of these facilities, and actually just completely labor unavailability. So
Hmm.
these facilities are really really struggling.
Yeah, for sure. And we'll talk about that for sure.
Yeah, yeah,
Because yeah, labor shortages are such a pervasive thing, but that I think are driving a lot of interest in robotics. But okay, so you have roughly 100 of these manufacturing like companies, or what, 100 sites, or how are we referring to it?
yeah, yeah. Facilities, yeah, sites,
100 facilities.
yeah.
And so what are some of the examples of like what you're actually doing? What are you helping them with
Yeah.
in those facilities?
So our biggest segment is producing consumer packaged goods. So we're
Hmm.
helping robots that we're putting in robots that help produce things like chocolate chip cookies and tortillas and matcha powder for Starbucks and dog food. Our robots make windshield wiper fluid, all kinds of things that are very commonly found in, Target or CVS or Walgreens or Walmart. So those types of products, have a kind of upfront kind of food production part of it, and then a lot of packaging related work that needs to happen. So putting items into boxes, putting boxes onto pallets, moving pallets into trucks or into shelving units. Those are all parts that are kind of very highly labor intensive. So we do a lot of those kinds of things with robots. Second
Hmm.
big category for us is metal fabrication. And so
Wow.
we have a lot of facilities that we serve that make components for automotive, aerospace, and defense. What a lot of people don't often realize is that, for every one kind of GM or Ford plant, there are typically, 200 to 500 suppliers that have to have facilities that make all the components that go to the GM or Ford plant for the final assembly. And so, there's this kind of very
Don't those
long.
suppliers also have suppliers? Like it just keeps going for
Exactly.
a long
Yeah,
time.
without a doubt, without a doubt. And in aerospace, it's even more, right? So for every
Yep.
single, Boeing plant, for example, you would have about 2 to 3,000 kind of immediate suppliers that are making components. Uh,
Our world is unbelievably globalized. It's just the craziest thing,
yeah,
with so many, I don't know, factories making so many specialized things and the networks and efficiencies of scale. It's
yeah,
absolutely unbelievable.
yeah.
Okay.
I love that. I don't know if have you ever heard of this example? Like nobody in the world today knows how to make a pencil. Right, because like even just a simple pencil, not a mechanical pencil, right? There's like so many disciplines involved. You have to chop the lumber,
Hmm.
create the paint, make the metal that holds the eraser. You have to create rubber. You have to create graphite. right? Like there isn't a single person in the world that knows how to do all of those things,
Hmm.
and let alone a more complicated product like a car or airplane. So I think
Yeah.
we're in a world where we're inevitably interdependent, right? I think anybody who spent time in
Yep.
manufacturing knows that, and you can't just improve one part of the supply chain and say, oh yeah, we solved that bottleneck. Like, that's not how it works, right? Like you have to provide a solution that all those few hundred suppliers and all of their suppliers can use if you really want to see kind of sustainable benefit.
Yep. Okay. So it's so when you do metal fabrication,
Yeah.
what parts are you involved with? Like, are you just moving the metal from here and there? Are you putting it into bending machines? Are you cutting it? Are you like where? What are the specific tasks that
Yeah.
your robots are helping with? Because it sounds like there's quite a bit of like logistics related things that you're helping with. But I wonder in
Yeah.
some of these other domains.
So in CPG, a lot of it is packaging and logistics. In metal fabrication, the most common use cases are machine tending, and so that could
Hmm.
be tending a CNC lathe, a CNC milling machine, a press, which is kind of doing the bending motions, welding, and inspection. These are all kind of very common use cases.
Ah.
So for example, one of our deployments, they're making metal parts that end up in a Chrysler vehicle, right? And they have to take thousands a day of these kind of individual components, um, cut them to the right length, put them into a CNC machine, let the CNC machine run a certain operation, then they take out the part and then put it into a lathe, have it do a secondary operation, and then take it out, deburr it, inspect it, and then put it into a box for kind of the next step of the manufacturing process. That historically used to be a person that would kind of stand there all day and kind of pick something up, put it over there, take it out, put it there. Like this kind of very repetitive process that was also fraught with
Mm-hmm.
a lot of error, um, and
Mm.
uh, and it was also very low utilization because imagine that process. You actually have 6 or 7 machines that are tied up
Yep.
in that one
They're not being
process.
used in parallel.
Yeah,
Mm-hmm.
and yeah, they're not being used in parallel, and you're very limited by the schedule of when you have
Yep.
labor available. And in typical American manufacturing facilities, especially in the metal fabrication world, they run one shift a day. Right, so one shift a day means they're running about 175 hours a month, which is about 30% of or depending on how I calculate, 20 to 30% of the available hours in a given
So you're
month.
saying for an individual, like the math you did was 40 times 4.5 to get 170 or something like that. And that's one person would work 175 hours and
One
this kind of thing. But
person, well, because
you
a
could
lot of
have
these
three
facilities,
shifts or something like
well,
this
but yes, but
if it was labor, if
in
labor could sustain it.
exactly right. There's not enough labor available, and so most American manufacturing facilities, especially most metal fabrication facilities in the U.S., do run one shift a day. Um,
Hmm.
so what that means is like there's just kind of massive underutilization, right? There,
Yep.
75% of the time these facilities are sitting idle. All of those machines that I mentioned, the CNC lathe and the mill, the inspection process and the
Hmm.
deburring machine, like all of those are sitting idle 75% of the time.
Most of the time.
So
Yeah, that's wild.
when we put that robot in there, what happened was, kind of step one, we helped fill an empty headcount that they couldn't hire somebody for. So kind of win already.
Hmm.
But step two, which was
Very much.
even better, was then they realized, well, actually, I can run this robot 24/7. So they would
Totally.
they would concentrate their labor on all the upstream processes to prepare the materials. They would load
Hmm.
up the robot, before they went to bed or left for the day. They would load up a bunch of blanks. They would go home and they'd come back in the morning and the robot had run another 10 to 15 hours of additional work. Right. So
That's
now
magic.
all the machines got higher utilization. The entire facility ends up being much more productive with the same amount of labor. and their part quality improved. They're able to win more business with
Consistency.
their customers because now
Hmm.
they actually have more throughput. So there's all of these kind of secondary and tertiary effects that come from being able to automate.
Very much. So the way I'm imagining it is, okay, we're understaffed because we don't have many people. So then what we can do, like there's not enough people for all the labor, all the jobs that we need. So now in this machine tending example, you have a person who is moving it from one machine to the next, and probably I wonder if they're doing like, so you start on machine one, it does the process, you move the part to machine two. Do you start another part on machine one and you just keep them moving so every machine is as fully utilized as possible, or does the person go and complete the part then start over? Because I'm
You're
imagining how robots could be more efficient, but
Yeah.
go ahead.
So you're supposed to do what you just described, which is
Hmm.
load the second machine, load the first machine,
As soon
and
as the
have them,
first one.
yeah, and have
Yep.
them run in
So everything
parallel.
is working as much as
Yeah,
possible. So you have one in operation, then two, then three, then four, and then you have the max number of machines.
yeah,
And say you have seven machines, you have seven parts
that's right.
now in circulation as they're moving through.
But in practice, the typical American manufacturing facility has a 200% per year labor turnover rate, meaning people.
Not as extreme as other industries, but that's pretty bad.
Yeah, I mean, for every headcount, they're hiring twice a year,
Yep.
which means
That's
that the
crazy.
person who's standing in front of that machine probably was only working for the last 2 or 3 months in that at the most, right? And most likely they're
Wow.
kind of at the beginning of their journey. So what that means is to train somebody to do what you're describing, which is like, oh, let me like make sure that every system is at max utilization is very hard. Most of the time, they end up being sequential, and
Yep.
so uh, like there's just so many things about that process that can be done much better when a
Yeah.
robot can actually kind of consistently meet that performance throughput.
Can you, so I'm imagining, okay, you have a robot. That robot knows roughly how long every machine that it's tending takes, and it has a few of them that it needs to do in series. You can probably do pretty intelligent scheduling. Is this something that you guys are doing? So you go basically, okay, I just started this one, I just started that one before that. I know when those are going to be done. I'm going to just, like, you could have one arm moving around doing one step at a time, um,
Absolutely. I mean,
pretty
all
efficiently.
of that ultimately boils down to kind of what is your average cycle time
Yep.
on every part, and so that's something we track religiously, and then
Nice.
is kind of automatically improved. So we actually kind of surface all of that kind of real time production data to our customer that
I
shows
bet they
them
love that.
exactly what your kind of part rate was on every different component in your process,
Hmm.
and being able to optimize it, is like one of the key
Oh,
parts of
it's
that, right? Like
killer.
what step do you do
Totally.
when? Do you deburr before you kind of load or unload, right? Like there's all these things that you need to figure out in terms of what the sequence of operations should be. And
Hmm.
Yeah, absolutely, like you said, with a robot, like you can create a recipe, right, and then you can make sure that you hit it every single time. But the other thing that,
Go
that
ahead.
that benefits from this, right, is part quality, right? Part quality goes up very
Yeah.
significantly because it's very common for operators who are standing in front of those machines to kind of load a part in an imperfect way, and they
Yep.
either tighten it too much or too little, or they didn't realize that the tool needs to be changed, or whatever it might be. Like there's a lot of different things that you need to pay attention to, and if those don't all happen, you end up with subpar parts. And worst of all, you often don't realize you're ending up with subpar parts until it's way
You
too
have
late,
it.
right? You've created a 2000 parts from today. Somebody checks them and
Oh,
realized, oh, actually, we missed something.
yeah, because you're just doing it the same way over and over again, with an error in your process for this kind of thing. But yeah, in a robot, you could just tell it the exact way to do it, and then it would just keep repeating that, which would be very nice.
That's right. Yeah.
Uh, so with the cycle time, do you have, so it's really wonderful that the robots can work 24/7 as opposed to just one shift a day. And it's crazy because people aren't as efficient because they're getting trained because the turnover is so intense. Do you have any idea how the cycle time of your systems, and I'm sure this is case by case, like application by application, But do you have a range of how your cycle time compares to person cycle time on various tasks?
Yeah, I mean, what we're seeing today is on average 30%, 30 to 40% improvement in cycle time.
Wow.
Um, but that improvement is generally the smaller one of the two. The bigger improvement is the increased utilization,
Time.
right? The
Yep.
fact that you can just run it for more hours in the day,
Yep.
um, because like what you're doing there is you're getting kind of 200% benefit or 300% benefit if you go from one
Oh yeah,
shift a day to
totally.
two shifts or three shifts.
Yeah, I'm imagining 130% of the products are being produced, and then you're also doing it for three times as much time. So that's
Yeah,
400, I don't know, 400% roughly,
yeah,
which is bonkers. That's really awesome as an improvement.
yeah, and
Oh,
you know, uh, typically, right, the constraints once you do that are upstream and downstream, right? Because
yep.
you
You
can
hit some other bottleneck because
exactly.
this part's highly optimized. I see.
Yeah. Yeah, exactly.
But then you can probably grow out to those if the types of tasks are well suited for what you're
Exactly.
doing. Because it sounds like I'm imagining the path of you guys. Maybe you started in logistics and then kind of grew into these manufacturing tasks. Because a lot of it's just assembling things in a sense,
Yeah.
like assembling your
We
Chips
actually
Ahoy
were
or
very
whatever it
focused
is.
on manufacturing from the beginning. We we
Uh-huh.
we kind of didn't we tried not to do too much on the logistics world, right? But I think
Because there are many companies doing it. Yeah.
there's already a lot of automation there, and also in the logistics industry, the kind of adoption rate of robotics is generally also quite a lot higher.
Hmm.
And so we felt like if we were going to have a bigger impact, we wanted to focus on the industry where like just robots make such a bigger difference. Right? The labor availability in a warehouse is actually much higher than the labor availability in a manufacturing facility because these are typically much harsher environments. Um,
Oh.
yeah, yeah.
Very interesting. But so the first set of things in the consumer packaged goods sounded more like logistics tasks. Did you kind of grow into that? Or
So yeah,
how did you
we're
end up doing those tasks?
yeah. So it's not even those tasks are not strictly logistics in the sense that we're doing
All right, I'm
packaging
just thinking
related.
palletizing
Yeah,
relating.
yeah. So
That's what
palletizing
I think of that
for
very
sure.
much as logistics.
Yeah, yeah. I mean, yeah. I think by that definition, that would be a logistics task. Although, um, like a lot of the other
It's one
processes that we
part.
do in manufacturing facilities, there's case packing,
Hmm.
and palletizing. There's also kind of different inspection applications. There's depalletizing for raw materials coming in. But you're right. I mean,
Hmm.
generally, what we call those are material handling tasks.
Ah,
Um,
okay.
um, because when I think of logistics, generally I'm thinking about kind of ASRS systems or typically what they're doing is kind of moving pallets around from one
I
place
don't
to
know what
another.
the ASRS.
Automated storage and retrieval systems. So those are like the kind of giant shelving units where you say, "Hey, I want a toothbrush," and then the robot will kind of go up to the right shelf and,
Yep.
and pull it out.
Oh yeah. Okay.
Yeah.
So what are kind of the core technologies that before we get to the configuration side, what are kind of the core technologies in your robot operation that you guys have? Like core capabilities that you end up using in various places across all of your facilities?
Yeah. So I'll kind of break it down a little bit by phase. So in the upfront phase, a lot of the software that we put to work is in automating the um, gathering of mission parameters, right? So if I walk into a factory tomorrow and they say, "Hey, I want to automate this task," um,
Hmm.
the immediate next thing that has to happen is I need to ask them about 300 to 500 questions, right? Right? It's like, what's the thickness of the concrete here? What's the ceiling height? What's the power that you have available? Do you have compressed air?
Do
What
they
order?
always know those?
And
Like, I mean, for
no, so
like
that's the other
concrete
challenge.
thickness,
Yeah,
like
you
they're renting the space. I don't imagine they know that part of the building, but yeah.
Yeah, exactly. The reality is like of the 300 questions that I need to ask, probably 70% of them they don't know, right?
Yeah.
And so it's like even simple things, right? Like what are your box sizes and weights, and what are your typical rates that you need to hit? What is the cycle time that your human is currently hitting, and how much do I need to improve that in order for the robot to be able to do better?
Oh my
Like there's
God.
just all of those, are just very, very difficult to know because your production is just changing so fast. So you have a production plan somewhere on somebody's laptop, right? But in
Yep.
reality, by the time that you show up on that site, like all of that information is outdated, and it's a act of God to go and gather all of that information. So we have found that uh, for robot automation in general, it doesn't matter what kind of robot you're trying to deploy. Like the first thing is you need to know what the robot needs to accomplish,
Yep.
and so um, uh, uh, gathering all that data is something that technology can assist very significantly, right? So we
Hmm.
use a combination of like lidar scanners to get kind of all the dimensional data about the facility within 2 minutes. We use 2D cameras to kind of observe some of the existing processes and automatically figure out what are all of those manual steps that need to
You
happen on a
just,
typical day.
when you say 2D camera, you just mean like a normal camera, not a
Yes.
depth
Yeah,
camera.
exactly.
Okay.
Yeah. So we put in a couple of cameras, we observe the process over a certain period of time, and we gather most of the application data that we need around like, what is the actual operation, what are the steps that need to happen, what are the rates and timing and things like that. And then we've created a bunch of different tooling for data ingestion where we can quickly connect to their
Hmm.
ERP or CRM systems, or whether it's an Excel file or other kind of scribbles that are on a piece of paper, whatever kind of structured or
Wow.
unstructured data they may or may not have, we feed that into our engine, which basically ingests all of that information and builds kind of like a mission plan, right? Like what does this robot need to do? What are the constraints? And how are we able to accomplish them? So that's
Super cool.
there's a lot of energy and effort that went into building that. Um,
Yeah. If you had to guess for this part of it, for the gathering the data part,
yeah.
is that like of say your man hours or person hours that have gone in? Would you say it's like a fairly substantial part? Like, is it like 50% of the whole effort of what you guys have done, or how
Um,
would you
f-
think?
from an R&D perspective, I would say it's probably about 30% of the effort that our R&D team has expended has been on building
Hmm.
this set of tooling. Um,
Hmm.
yeah, it's not insignificant, but the hard part about that, about building this kind of data ingestion pipeline, is
Hmm.
two things. One is actually building it, right, which is hard. But
Yep.
really, the really, really hard thing is knowing what are the right things that you need to ask. And
100%.
like,
Yeah.
what are the qualification points for every type of task? And that requires a lot of end-to-end experience, right? You can't kind of design those in a
Hmm.
vacuum. You need to deploy a bunch of systems and then realize I should have asked this question uh, right early
Very
on,
much.
and that would have really saved me a bunch of time or design effort or whatever it might be. Just like a simple thing, right? Like, what is your ceiling height, right? Like, if you don't ask that question, you can very much end up
Yes.
stuck. So, uh, uh, the effort that is expended by the kind of R&D team to build it is one part, but really the effort that is expended to um,
The
uh,
iteration.
yeah, like
Hmm.
take that knowledge that like a seasoned engineer would have in their head and turn it into kind of software that does it automatically. That's really where the
Uh-huh.
majority of the work is.
Yep. And so with that part included, so the
Yeah,
R&D for like how it works, that's been 30%.
yeah.
For the iteration and having those really powerful heuristics of like what kind of information and what things we should even ask, that's probably an ongoing thing, I would imagine. But I
It
imagine that's been a big effort too.
It is, yeah. It's a continuous effort. It's very hard for me to estimate kind of like what percentage of our time and energy went into that
Yep.
because it kind of permeates into everything that we
It's
do.
continuous.
Yeah, like
Yeah.
as every time we deploy a system, we look back at, did we get the things that we needed? What are the challenges that we encountered in the deployment, and how do we use that to improve our kind of upfront screening process?
Yeah. So you have the LiDAR, which gives you a good, like you're getting a 3D map
Yeah.
of the environment, and
Yeah.
then you have this data ingestion part. Is there anything else that you have in the initial setup for this kind of thing?
Um, yeah, I mean, so a lot of it is just kind of pure software based, right? Kind of
Yep.
ingesting text and PDFs and whatever files that they
Yeah, and the
have.
gesture has a lot of things in it, I
Yeah,
imagine.
yeah,
Like it's a complex,
yeah.
big combination of bunch of software.
That's right. Yeah.
But
Um,
mhm,
so then, like all of those kind of mission parameters get fed to system number two, right? System number two is really where um, I think there's much more like difficulty, right? So system
mhm.
one is like technically less difficult, but operationally very complex. Uh, Section two on our software tools is what we call fast Formic automation software tools, which is basically what allows us to rapidly configure a robot work cell. And what that
Mhm.
means is we take all that information and we say, okay, what is the solution here, right? For this set of mission parameters, what type of robot do I need? Do I need a big robot arm or a small robot arm or a collaborative robot or a gantry robot? Do I need safety fencing or do I need area scanners? Do I need this kind of conveyor or that kind of conveyor? What is the height? What is the depth? What is the cycle
Mhm.
rate? What kind of end of arm tools do I need? That used to be a process that was highly manual, where a person would basically spend months, going through all of those
Mhm.
iterations and simulating all of them to figure out whether or not you meet the demand. And what we've built is really basically an automated system configuration tool, right? So we take those mission parameters, we feed them into our simulator, we iteratively cycle through different robot designs
Oh,
and
wow.
choose the right system for that task, as well as all the peripherals associated with it. Um, and then we run that robot in simulation to validate what the cycle time is going to be, right? Because the cycle time is often a function of capability. So, like, let's say I only need to hit 4 cycles per minute. I might be fine using a collaborative robot, and that collaborative robot means that I don't need to have area scanners. I don't need to have safety fencing, and a lot of things get much simpler. Uh, but if
Mhm.
that cycle rate goes from 4 parts per minute to 12 parts per minute or 20 parts per minute, um, your physical footprint may
Can't
stay the
use your
same, right? But all of a sudden, you
mhm.
like there's these cascading implications into all the different components that go into that work cell. And so
Mhm.
as that starts to happen, you encounter a trade-off, right? You say, okay, well, the customer told me they only need to hit 5 parts per minute, but should we design it for 7 or should we design it for 4, right? Like, and like we have to kind of gather all this information,
Mm.
and that's quoting and pricing and lead times are all highly interdependent on all those design decisions,
Oh,
right?
100%.
And so
Mhm.
at the end of the day, like it's not a matter of uh, 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 kind of yeah, you can't make those choices in a vacuum. And the way that it happens today typically is um, every robot vendor has some system, right? They're like, well, I only make these systems, right? And so if you were a manufacturer and you go to them and you say, hey, I want a robot that loads and unloads a CNC machine, they'll say, well, I have this, right? And that may or may be the right thing, may or may not be the right thing, but you have no idea of knowing, and the supplier also is unlikely to know because they're just trying to sell you the piece of equipment that they have. And
Yep.
so this is where the kind of power of our business model comes in, right? It's because we are committed to the performance of that system for the entirety of its life. Uh, when we deploy a robot and we say we're going to hit 10 parts per minute, we are committed to hitting 10 parts per minute from the day that it arrives until the day that you say, yeah, until the day that you're done with your contract. And so
Wow.
that requires a whole different level of design, and we are then incentivized to make the right design choices, right? Like, what is the thing that's going to
Definitely.
meet that target consistently?
Yeah. We talked about this in our first call.
Mm.
Like the Alex Hormozy idea of they'd have to be stupid to not do it kind of thing.
Yeah.
So I mean, you're like, we're gonna make it so that we are hitting your targets from day one for this kind of thing, and we're gonna guarantee that, and fill these labor shortage gaps and make it so you have higher utilization. This is all
Yeah.
awesome.
And it
And
requires
yeah,
putting a
that
lot more on the line, right? Than the
yep.
typical robot supplier who says, I'll sell you the thing. You figure out how to live with it.
Yep.
We are set up where we take a lot of risk on, right? If we deploy a robot and it's not getting used, that's bad for us, right? So
Hmm.
we do a lot post deployment to make sure that the customer is continuing to get the most value out of that system.
Yeah. I also imagine because you are providing metrics and everything, like if you're coming in on a customer and their supply, their manufacturing process is constantly changing due to changes in demand or whatever it is, seasonality, anything, and they're not tracking metrics very well, like you're coming in and you're adding a lot of value there as you supply them metrics, help them figure out where they have bottlenecks, help them optimize other parts of their process.
Yeah.
Hmm.
Yeah.
So
Um,
that, oh, go ahead.
Yeah, I was going to say, so this kind of automated robot configuration process, the thing that's related to that is also automatically generating the robot program, right? Like to get the to
Hmm.
because to run the robot in simulation, you need to have a fully functioning robot program that does that
Hmm.
task, and so that's another area where we spend a lot of energy is automatically generating the program for the robot so that we don't have to spend a lot of manual time kind of configuring it to do the task. So that's a kind of where generative AI comes in to really help speed up
Hmm.
the robot programming process.
So I'm imagining with generative AI, I don't, my current model of it is that it's not that good at very fine details for things. So if I wanted it to like write the full program in C++, that'd probably be hard.
Yeah.
But it can probably pick action blocks very well for assembling your program to accomplish some goal. How are you guys using generative AI? Is it like higher level behavioral things, or is it pretty low level, or what kind of things are you doing there?
Yeah, so it's a mix of the two. So there's some selection of action blocks, but there's also some modification of those action blocks based on the components that you select, right? So if you use a vacuum
Cool.
tool versus a clamp tool, or if you use, a vacuum tool that has one zone versus three zones, like that's a design choice that you need to make.
Oh,
And then all of a sudden that impacts your programming because if you're doing, if you're, let's just, sorry, I'm, going into detail, right? But to give some
no, I want to
specific
hear it.
examples, right? Like if you have a three zone, if you, in order to hit, like, let's say the 9 parts per minute rate, you might have a robot cycle time of 3 cycles per minute, but you triple pick, right? If you pick three at a time, you can hit 9 parts per minute. If you're picking three at a time.
Just
Um,
do three, yeah.
yeah, and so
Hmm.
what that means is one, you have to validate that the robot can hit the weight, and all the things associated with picking up three at a time. You need to have end of arm tool that supports that. You need to have an indexing system upstream that supplies 3 parts at a time for the robot to be able to pick 3 parts at a time
Huh.
at a fast enough rate. And then you need to have your programming configure that, right? Because if you're picking up 3 parts at a time, you may not want to drop all those 3 parts in the same way, right? You might pick up 3 parts
Oh,
and you need to drop them separately. So then you need a vacuum
yep.
tool that has 3 zones. Anyway, like maybe I'm going into too far into the weeds, but
No, no, no.
the
This is
thing I'm
great.
trying to demonstrate here is that it's not just a matter of drag and drop the action block, right? Pick up a part, drop a part, right? It's not as simple as that. The reality is once you've made those design decisions, you have to modify all of those action blocks, and you need to see what that cycle time looks like
Hmm.
in the real world, and then you may need to come back and change some of those design decisions again, because if you pick up three at a time, but your indexing system is so slow that you end up having a low cycle time, you may be better off picking 2 parts at a time or 1 part at a time. So
Hmm.
these things don't scale linearly, right? And I think this is where what we found, and this is kind of going back a little bit into my career as a VC, what I found is that a lot of robotics companies were very, very focused on how do I make the robot pick the thing up and drop the thing off as
Hmm.
efficiently as possible? How can I make it so smart that I don't need to tell it anything? I just need to pick up the thing and put it down. But the reality is that doesn't actually solve for all these things that we're talking about, right?
Hmm.
How do you index the part? Where do you drop them? How do you drop them? What is your kind of upstream and downstream constraints? Um, what robot do you select to do that task? All of those are design decisions that need to happen. Um, And what we found is like a lot of robotic startups feel like that's the dirty work, right? They're like, I don't want to get involved in that. I just want to provide a software API, and I want everybody else to
Yep.
figure out all those things. And like the reality is like that means that nobody's going to be able to adopt, right? Because
Yep.
um, that's really where the rubber meets the road.
Yeah, very much. Yeah, I've seen a whole bunch of robotics companies that make a product and then drop it off. And
Yeah,
that or they have to do all of the custom work of fitting it to the warehouse or fitting it to the manufacturing facility or whatever every time with every customer, and it's a severe limit on their scaling
yeah,
ability.
yeah,
Um, so like what you guys have worked on, and I guess this probably goes back to your VC experience, is it seems like you have gone right to the hardest part, which is the configuration, so that you can scale a lot easier.
yeah, yeah, yeah. I mean,
Uh-huh.
using reinforcement learning to do the pick and place part
Yep.
is table stakes today, right? Like I've gotten
Yeah.
pitched on that, probably 100 times in the last 2 years, right? And I continue to get new people coming to me every day and saying, "Oh, I'm like a really really smart, Stanford graduate, and I have this really great way to like pick up things and put them down with the robot, and I'm going to save you a whole bunch of money on your programming costs." And then the reality is like that's not true at all, right? Because programming the robot to pick the thing up and put it down is maybe 2% of my deployment frustration, right? Like
Yeah.
98% of it is all these other things.
Yeah, for sure. And especially as you want to grow, like the point of a startup is growth,
Yeah,
I think. And if you're effectively, I've been thinking of a lot of companies as like making a distinction where you have startups and those are focused on growth, and you have contractors that are focused on they may get revenue and they may gradually be able to get more efficient, but they are very often doing things that don't scale very well for a long time. And they
yeah,
may call themselves a startup, but they very often are effectively just consulting around the problem they're solving.
yeah,
And so you guys, it seems you're very much growth focused
yeah,
for this kind of thing.
yeah. Um,
For the,
Sorry, go
oh, go
ahead.
ahead.
Oh, I was gonna
For,
move on to the next block of software that we've built, but
I
if
want,
you have questions on
I
it, we
still have
can
more
continue.
questions for
Yeah,
this. Yeah, yeah. So you mentioned reinforcement learning as a way of doing this. I was wondering, how are you, actually, going back to just the generative right before the reinforcement learning, generative AI. So the way that I'm imagining it, and maybe this isn't quite correct. So largely you're selecting actions, but you're also modifying those actions. That's really cool. Is it like you have small parts of it that you let it? So they're like
yeah,
this is a larger action, and we're saying, okay, I'm scoping you. You
yes,
can do this one thing. You're writing this input output
that's exactly right.
effectively
Yeah, we
for
basically
this.
give it a template of what we want it to build, and then we say
Hell yeah.
here are the inputs that are different uh, from kind of that's phase one, right? Like as we gathered all
Yep.
this data, we generated these kind of requirements. Here are the requirements. Here's the template I want you to fill. Here are the things that we need to figure out, and it fills them out.
That makes a lot more sense to me
Yeah,
because the other one would be pretty finicky, I would imagine,
yeah,
in terms of like it works sometimes, but it wouldn't work a lot of the time.
yeah,
But
exactly.
confining it would be much better.
Yeah,
What are you using? Like, are you using like Facebook's LLM or Meta's LLM or how? I'd be curious about your specific generative AI, um, I don't know, program or service you're using for this kind of thing for this. I
yeah.
would imagine that it would probably be Meta's Lambda model,
Llama, yeah.
but
We use
Llama, yeah,
Llama with some so
modifications.
yeah, with some
Or
modifications and a bunch of tooling around it.
hell yeah, it's
Yeah.
cool. It's a neat thing. Yeah, I was imagining as a company, you don't want to use like Claude or something directly or ChatGPT directly for this kind of thing. Having your own control of it would probably be good. Not having them like ChatGPT
Change
releases
the
a new
model on
version, it
you.
breaks all your stuff.
Yeah,
Yeah,
yeah, exactly.
or
Yeah.
just some crappy update
Yeah.
or something.
Yeah. 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 But I mean
Cool.
the good thing is right the quality of these multimodal models is
Just
getting so much
increasing.
better so fast that like we can start to
Totally.
ingest more and more types of things and skip more and more of
Yep.
the steps. Yeah.
Hmm.
Yeah.
And then so just so I understand your fast automation tool a bit more, you are the way I'm imagining it is you have your ingested data, which gives you a structure in a sense, like you're inferring some sort of requirements from your ingested data.
Yep.
And then from that, you are going to, given constraints of things you've observed, you're going to try to figure out what's the best way to meet the customer's goals at the lowest price
Yep.
for this kind of thing.
Yep.
And then to do that, what you do is maybe you use LLMs again, and they're selecting like base components or something like this. And these are like this robot here, this kind of thing. And then you are running that in simulation with a good way of establishing metrics for it and seeing how it does, or how does all
Yeah.
this work?
So you could think of it a little bit as right, like instead of human in the loop, like we have kind of AI in the loop, right? So like the
Yeah.
core of what we're doing here lives in the simulator. So our
Yep.
simulation tool takes those takes that configuration information and then generates and runs, the full work cell based on what it has available. And then the AI, what it does is it kind of looks at the performance data, right? It says, look, cycle time is too low, change this. Or space constraints are being exceeded, change that, right?
Mm.
And it goes through this process where it iterates through a couple of different variants, and usually
Hmm.
what it spits out is kind of three or four candidate configuration files, right? And that's where the human gets involved, right? Which it says, hey, we have kind of
Oh.
option A, which is $100,000 of cost, using a collaborative robot, and we're able to hit 4 parts per minute. And, option B, it's $150,000 of cost. It's an industrial robot. It takes a bigger footprint, and it can hit 8 parts per
Hmm.
minute. Option C is a gantry robot, and it can do blah blah blah, and it can hit 12 parts per minute, whatever it might be, right? And it'll kind of generate those
Yep.
options for us, and then then we do have humans in in the loop, right? At that point, who look at those configuration files and make the kind of business trade-offs related to it, right? It's like,
Yep.
okay, what are the like if I want to hit the hourly rate that hits that saves money for this customer, and we want a system that's relatively redeployable. If that product mix changes in that customer's site, which of these, option A, B, or C is going to be the better fit,
Hmm.
right?
I
Because
really like that you do that. You give them options
yeah,
and
well,
then
because it's
let
not
them fine tune it.
yeah, it's not static, right?
Nope.
The product requirements are not static. What you might have today, is something that only needs to hit 4 parts per minute. But 3 months from now, you may win a new order, and you might
Hmm.
have to, increase that, to 12 parts per minute. And like, you don't want to have to rip out that whole system and put in a new one. So you need to kind of
Yep.
design for a couple of potential changes.
Hmm. That's super cool. Okay. So can you tell me a bit about your software stack? Like, are you using ROS? Are you using IsaacSim? Are you using like, do you make your own stuff?
Yeah.
What,
We're not using ROS. We are using yeah, Isaac simulation for our like hardware and loop simulation processes.
yep.
We also use another tool called RoboDK,
I don't
which
know it.
yeah, RoboDK is a robot simulator, that there's a
Did
lot
that
of
give you a
there's a lot of
bunch of
benefits.
off-the-shelf robots for this kind of thing?
Yeah,
Was
they
that
have the
the
one of the big
benefit there?
benefits is they have a huge template library, that we can use. So like
Hmm.
they have
Cool.
all the configuration files for kind of most of the off-the-shelf robot arms that we might use.
Oh,
Um,
that's super cool.
and they like the to because a simulation in
Oh,
a
is DK, is that developer kit? Like it's like SDK,
actually I don't
but
know what it stands for. I don't know what it stands for. Maybe, yeah,
because
I
robot
should ask
developer
them.
kit.
Could be,
Okay,
yeah,
just guessing.
yeah, it could be.
Based on
Um,
your description, that's kind of what it sounds like.
yeah,
But okay,
yeah, yeah.
so you
So
use that. You have IsaacSim for simulation,
we built a
robot
bunch of
DK for robot
plugins.
configuration.
Yeah, we built a bunch of plugins that go on top of RoboDK that kind of automate a lot of the steps for it.
Hmm.
Um,
Okay. Hell yeah. And then, okay, so that's the fast part of this,
yeah.
your automation tool. What goes on top of that?
So the next phase is build validation, right? So it's one thing to have like the perfect robot designed in simulation. Then physically building it often means that you end up with a bunch of differences, right? um,
Hmm.
we some of them we built in-house, but most of the time we use third parties who build the hardware for us based on our configuration, right? So we say we need this robot arm
That's
and this
cool.
conveyor and these sensors. Um, and what as that system is getting built, you need to validate everything, right? If
Yep.
even one of the if even one of the sets of wires are installed backwards, right? Which happens all the time. Um,
Yep.
all of a sudden, the performance of that system is works wrong, right? Like if this sensor is connected to that I/O and it's the wrong one, right? It expects that the other sensors connected to the I/O, like your performance all just kind of goes out the window. And so
Hmm.
we've built a bunch of tools that we send an industrial PC to every system builder, and as they build the system, uh, that
What's
that
that?
that industrial
What's
PC gets
PCE?
industrial PC, which is an industrial computer.
Oh, I see.
Yeah. So
Yeah.
the industrial PC, uh, sits in the control box, connects to the PLC, the robot programming, and sorry, the robot controller, and all of the other peripherals, and it validates that everything was done correctly. So it
Hmm.
has essentially it's unit tests, right? In software, it's very
Yeah.
common to do unit tests. We basically do unit tests for hardware as well. So we'll have the robot, do a certain movement, block a certain sensor, and then we'll say, did we get the reading that we expected from that sensor or not? Or
Huh.
we will have the robot automatically trip some of the safety um,
That's so
and
cool.
and then see if that triggers the response that we were expecting or not. And so we're able to validate that the built
The
system
setup is what you expect.
performs in the same way exactly as the simulated system.
How do you, so I'm imagining this is all, again, so not fully, I mean, it's probably somewhat generated, but largely templated
Yeah,
for this kind of thing, where
yeah,
you say, okay, we added a camera, let's make a movement that blocks it for
exactly.
this kind of thing.
Yeah, yeah.
That's
Yeah, so
super
it's like
cool. I really like that approach.
our deployment project manager will have a kind of a validation checklist for every system, right? They'll say, hey, here are the 23 things that we would check if we were on site. Um,
Hmm.
what percentage of those can we do automatically?
That's awesome. I really like, because these are things that are time consuming for most companies.
Yeah,
And I really like that you've spent the time to automate them. And
yeah.
I also feel like, well, I'm curious, because when did you said you guys have been running for like 3 years or something,
Almost
right?
four,
Like,
yeah,
do you say
three and a half.
21?
Yeah, end of 2020 is when we started.
End of 2020.
Yeah.
How much, I guess, did you pivot quite a bit with generative AI? Because like OpenAI came out, I don't remember when that was, like 2022 or what, like end of 2022, or am I wrong?
Um, I don't remember exactly when OpenAI came out, but we didn't
Did you pivot
pivot.
kind of hard, or was it just it assisted in what you were trying to do already? Or
Yeah, these were all things that were on the roadmap from the beginning. Um,
yep,
they just became much more capable, right? As LLMs started to get much better. Now
yeah,
all of a sudden these tools started to become more capable. Although, a lot of these things that we're doing don't have anything to do with LLMs, right? Like the kind of simulation piece is not really related to LLMs. The, robot performance validation set is not really related to LLMs. So, I think AI has a part to play for sure.
yep,
But a lot of these things, have to draw from a foundation of a bunch of different things that people have developed over the
definitely,
last 20 years. Yeah.
yeah, very much. Yeah, it is quite cool. And I guess you could have just always had a human in the loop and you in some specific parts, and it wouldn't have been that much of a slowdown, most likely.
Yeah.
But you get better efficiency using these kinds of tools. And even if a person then curates it, or says, these results suck, run it again, or whatever it might be. How does your data ingestion part work? So if they have like scraps of paper and things like this, or how do you getting that initial data of their setup? I understand the LiDAR scan, but understanding a lot of the other things about them, How does that all work?
Yeah.
That sounds like a thing that LLMs would be pretty good at.
Yeah, that
But
that is something that helps a lot. So usually what happens is our salespeople who go on site um, know all the things that they're supposed to gather, and they just kind of take pictures and videos of all the things that they can, right? So if the guy who's working on the site is doing a certain set of motion, take a picture of whatever they've kind of
hmm
written down. If we have
Yep.
boxes that have serial numbers and weights and sizes that are written on them, we'll take a picture of that. That whole set of things that gets loaded into our kind of configuration tool, right? And so that's what generates the mission parameters. So it can come in a variety of different formats. It can also even come in the form of audio recordings. So, like our salespeople use Chorus, which is the tool that kind of records meetings. Usually in those meetings, a lot of the information that we need to gather can be is asked and answered, right? So that also gets
hmm
fed into the same model for that project. So every project basically has a set of context data that is given, and then the LLM is responsible for filling out this
Form.
this form,
You
and
have a data structure effectively.
yeah,
It's filling it out.
exactly, and then
hmm
surfacing the things that it doesn't have. It says, "Hey, nobody asked about this thing that I need to know.
Ooh.
Can somebody go
How,
back to the customer and ask it?" Right?
how do you do that? Because that's a very interesting thing. Because LLMs are not that good at knowing what they don't know. And having it be like, I don't have this information is very interesting to me.
Yeah, I mean, a lot of that just comes with like the right kind of prompting, right? It's like, do you know this or not? Can you find the
Oh, did you see
example?
this or
Yeah,
no?
exactly.
You say yes or
Yeah,
no. I
yeah,
see.
yeah,
Yeah.
yeah.
I since ChatGPT, I have been looking for how to use LLMs in some way to make my podcast posting more efficient.
Cool.
And it's very funny because I feel like in some sense it's like I'm trying all the things right as they're available. And so it's a very good excuse to become quite familiar with them. But it's very funny how tough it is to reduce some hallucinations.
Yeah,
Um, and but I guess just asking, did you see this? And if so, what is it? Kind
yeah,
of thing. It's no, I did not see it. It can probably answer that pretty
yeah,
reliably.
yeah, yeah.
And then you can ask it to check itself for this kind of thing.
Exactly. Yeah,
And the new Llama model, I can access it through Perplexity. I haven't actually run it locally. And the Claude 3.5 Sonnet are really good.
yeah,
Like they're genuinely useful, which
yeah,
is just super, super cool because nothing was useful until Claude Opus for
yeah,
me.
yeah. Well, I mean, I think the thing my perspective on a lot of these LLMs is that the large language model themselves are never going to be perfect, right? Like the thing that
No.
matters is if you have a good filtering mechanism for the output that comes out of
Yeah.
it, right? Like you need to have rule-based things a lot of the time that check the
Hmm.
output of the AI model. Because oftentimes you know what your expected output should be,
Yep.
it's one of these few options or whatever, right? And so the LLM is not very good
Yep.
at sticking to the right answer, but you can check that with a rule-based system. And so like you kind of need to, I feel like you
Yep.
need to sandwich the LLM between upstream, you need to uh, uh, like give it information in a very specific way, right? That's the
Yep.
prompt, right? So you kind of constrain the input, and then on the output, you need to sandwich it with another rule-based filtering mechanism, right? So like it does whatever it's going to do
Mm.
in its black box, but you have a screen for what actually comes out of the other side, so that
Yep.
you kind of constrain the problem a little bit better. Because
At both ends.
yeah, most of the time, like you're not going to ask, like I'm not going to ask an LLM to write a poem for me, right? In the context of Formic, right? So
Yeah.
like I know that I can limit the kinds of
What a
outputs that are going to
clause.
come,
Yeah.
right?
Yep.
Yeah,
Yeah. Very, very true. Yeah, it's an interesting time with
yeah,
all this.
yeah,
Okay. So you have your robot DK and the simulation, and you are performing validation on the actual hardware to make sure that it is working as you would expect. What do you do from there? I guess do you install it in the customer's site, or how do we proceed from there?
yeah. So the next step is usually we do a full acceptance test, which I described parts of. Right, we do the acceptance testing at the system, whoever's building the system for us, we run a full acceptance test. If it passes, we ship it to the customer site. we install it, and then we run a secondary acceptance test that is in their environment, right? Because there's usually differences
Hmm.
for a variety of different
Yeah.
reasons. And we do that acceptance testing. That usually happens in about half a day. And then we also generate a bunch of like peripheral information. So it like usually that looks like kind of training handbooks for the operators who are there. Right. So
Cool.
because you have a bunch of people who are interacting with that machine, and so you need really, really clear instructions for how to interact with the robot if you've never been around a robot. How do you start it? How do you stop
Yeah.
it? What do you do in this error? What do the different lights mean? And then we also put kind of QR codes on all of the components. And so
Oh, that's
the
smart.
they can scan the operators who are on site can scan a part, and then it notifies us, right? And we can kind of log in via telepresence, and we can ask that operator questions, and we can also kind of surface little video files that say, hey, here are all the things that you can do to resolve this issue, right? Like if a suction cup is blocked, check and see if there's
Yep.
some if there's debris in there, or if there isn't, hit this reset button or call us or we'll come on site or whatever it might be, right? So um, uh, we generate those procedures up front, and then we have a bunch of software that we call Colony, which is basically our kind of robot management tool set, which allows
Hmm.
us to remotely manage and monitor all of these systems that we've deployed. So we kind of every system has
Did
20.
you build that? And that's internal? Like
Yes.
it's a tool you guys have developed? Okay.
Yeah, we built it internally. We tried to not have to. We tried to kind of evaluate other
Yeah.
ones that were out there,
They
but
didn't meet your needs.
they didn't meet exactly the things that we needed. Yeah, exactly. Because our use case is a little bit complex, right? Like one is we need to not just monitor the robot, we need to monitor all the peripherals, right? So
Hmm.
all the servos and PLCs and conveyance, all of that needs to be monitored as well. So um, there's complexity there. Number two, we kind of need video data from multiple cameras on that work cell at all times. Three, we need to be able to intervene when there's an issue. And so about
Oh.
60 or 70% of the time, if there is an error on the robot, we can resolve it remotely without having to come on site. And so that saves a bunch of time and cost.
Oh, for sure. Yeah.
Um, and so, we just had all of these kind of relatively unique needs on our robot
That didn't
fleet
exist that
management
well.
tools. Yeah.
Okay. Very cool. Do you have when someone has to intervene, is it like so do you know Plus One Robotics
Yeah.
and their setup?
Yeah.
So they have a pretty sophisticated, like to me, like the core competence, maybe not core competence, but one of the big differentiating things about them is that they have a very good workflow around human in the loop for when
Mm-hmm.
their robots get stuck.
Mm-hmm.
So they're trying to pick up a box that I taped together to ship back an Amazon package, and it's total chaos
Yeah.
and it's falling apart. And so then they have a human say where you can pick it up, or should it be discarded, or whatever, or not discarded, but like reprocessed or something.
Mm-hmm.
Do you guys have a similar human in the loop system, or how do you handle these kinds of things?
Yeah. So for handling edge cases, we do have humans in the loop. So we have our service engineers that are monitoring all the systems 24/7. If there is an
Hmm.
edge case that needs human attention, it kind of pings one of them, they log in and they can remotely support. The uh, the amount of things that a remote person can do is quite limited though. So we do have to
Yep.
kind of design for it up front, right? So we need to put in place procedures for what happens if different kinds of errors are tripped. To
Hmm.
your example about tape, like one of the most common failure modes for a palletizer, which is one of the simplest system types that we deploy, the most common failure mode is that the box has not been taped properly. So the robot
Yeah.
picks up the box, but if
And
there's
a
no
flap
tape,
lifts up or something.
yeah, or if there's no
Hmm.
tape on the bottom, all the contents just spill out. uh, so that's a
That's a
common
bummer. Yeah.
occurrence, and it's not the robot's fault per se, but because we're committed to overall uptime and performance, like we still need to detect that situation and avoid it before the other stuff. So we have a vision model
Wow.
that trains on tape detection or flap open detection. And if it detects the tape is missing or the flaps are open, it either pauses the system, or if there's a place for it to push to the side and keep running, then it will do that. And
That's
so,
great.
there's every system type has a bunch of different failure modes that you need to account for, and you need to
Hmm.
build into the system.
Hmm. Now, let's see, going back a little bit, um, when you said you build a document, like a technical or some sort of document for the workers so that they have exact information on the system you've set up, I imagine that that's fairly similar to a number of the things we've talked about where it's largely template driven, and then also like you have templated text that you put throughout, but then you also have custom text using LLMs for this kind of thing. Is it the same kind of thing?
Um, Yes, there's a little bit of it that's automatically generated, although there's a human, kind of heavily involved in that. But
Yep.
I'll say that the challenge is, in a real production environment, it's very unlikely that somebody's going to stop what they're doing and go read a handbook.
Yeah.
Um,
But you probably want quick reference points for this
yeah.
kind of thing.
So the way we
If this,
generally
then do
do
this.
that is with video. So we have
Oh.
10 or so, 10 to 20 different kind of common failure modes that we've accounted for. And we just pop up a little video on the screen of that robot that says,
Huh.
hey, here's what we think might be happening. Here's the steps that you take. And hit this button if it's not resolved, and it'll call us. And then we can kind of
That's
help
so cool.
diagnose.
So you like pull up the YouTube video they need to see, but it's
Exactly.
internal
Yeah,
probably.
exactly.
That's super cool. So
Yeah.
yeah, you're not focusing on the documentation because they're not going to use that to solve things, but you have uptime requirements.
Yeah.
And so you have a very streamlined process for them,
Yeah.
which often is this is a video of exactly what you need. And you have through your through collecting data, you understand a lot of the common things that may go wrong, and you probably have some ability to introspect the robot to
Yeah.
understand what may go wrong. And then you pull up the correct video, they watch it, they clear it out, or they call you guys
Yeah.
if they cannot
The
figure it out.
the most common sequence of events is that, like, the first thing that people do when the system goes down is they call us, right? So they'll call. We have a 1-800 number. They call us. One of our technicians answers. They ask them a few questions, and they say, "Okay, here's the issue," and we can remotely trigger the video to start getting played on the screen. So we say, "Go to the screen, look at this video. It's going to tell you what to do."
When are you going to do LLM's voice for your technician to just direct them to the video?
I think we're a little bit of a ways away from that still, but hopefully one day.
Yeah, yeah, hopefully one day.
Yeah.
I wonder. Um, for so one thing that is interesting to me about you guys so far is that it seems like you're doing your technical support for your customers in-house. Several other companies that I don't know have scaled and maybe are a bit further along, they seem to outsource technical support for this kind of thing. And I'm just wondering about, I guess, your view on technical support, and is it something that should always be in-house, or how
I,
do you think
I
about it, I suppose?
Yeah, I'm gonna sound a little bit like an asshole saying this, but who's further along? I mean, I don't know of any other robotic startups that are in 100+ manufacturing or 100+ facilities.
Not in manufacturing. I'm thinking
Even in
of,
logistics, right? They're typically in
yep,
3 to 5 facilities, maybe 10, maybe 20 if they're
yep,
really, really pushing it. There's very few robotics startups that actually are managing a fleet of systems across 100+ facilities. And so
yeah,
so I'm not saying that to kind of push, right, but what I'm saying to say is
yeah, yeah.
uh, I think that outsourcing service and maintenance is one of those things that sounds nice, right? A lot of people are like, yeah,
It's
well, like,
hard to.
I can't scale if I do
Mhm.
it myself. And that's just a very common, like, fallacy that I think a lot of robotics companies fall into, where they say, I want to do the things that scale, which leads
Yep.
them to, I just want to provide an API and I want to let somebody else do all the work, right? And it's like, that's not
Yeah.
the hard part. That's the hard part, right? Like, doing service and maintenance is the hard part.
Ah.
That's the whole key, right? If you don't do that, your solution is worthless. You can't just drop it off
Ah.
and give it to a third party. And I think this is where if I have any advice to give to robotics companies, it's like don't think you're too good to do maintenance. Like don't think you're too good to write, documentation. Don't think you're too
Yep.
good to kind of go and custom design end of arm tool, because those are the things that are necessary to drive
Hmm.
massive adoption. Um, Deploying systems in 100 plus facilities is a Herculean task.
Yeah.
That is, there may be other companies that have more robots deployed than us, but they may have 100 robots deployed at one facility, for example. Right? Like that's a
Yep.
totally different class of problem than having robots deployed at 100 plus facilities, right? Like every facility has a bunch of its own idiosyncrasies. You have different people you have to interact with, different operators,
Definitely.
smaller amounts of training, less on-site support. So it's just like I think we've gone much farther on solving the kind of post-deployment issues than I think anybody else on the planet today.
Hell yeah. Okay, super cool. Yeah, so you view it as kind of a core competence of the company to basically be able to service its robots over time. Because you're right, you can't really just drop them off, and if the people that are supposed to maintain them are not super good, and you may get some variation in quality, then that's a mixed experience for customers
Yeah.
for this kind of thing.
And I mean, I think if it depends what your goal is, right? If your goal is to sell robots and get them out the door, then maybe you don't need to do what we're doing. If your goal is to have robots deployed and be useful for a long period of
Aha!
time, and like what, because
You need
the
that.
metric that we track is not sold units. The metric that we track is usage hours. Every month, every
Love
day, every
it.
morning, we look at what are the number of usage hours from yesterday on our robots. Did they actually do useful things for 10 hours a day or 1 hour a day? um, and if your metric is that, then you have to be responsible for the
Hmm.
service of that system. If your metric is did I sell things and like get them out the door, then yeah, you don't need to track how they did once you've sold them.
Hmm. Yeah. Yeah, I really like the idea of using usage hours as your proxy for success because I think a lot of times with new technology, what happens is a lot of bigger companies, like huge companies in manufacturing, but agriculture and other places, they'll buy technology just to try it out. And it looks promising
Yeah.
for the startups that are getting these early trials, especially if it's a prominent company. But then it's not always a land and expand. It
Yeah.
may be a try or we'll just keep you at the same level for this kind of thing to see how it develops over time or something like this.
Yeah, I mean, I think the most damning thing is a lot of these robots get deployed into innovation centers, right? Instead of real production environments, right? And like they think of it as a point of pride, where it's like, oh, I got deployed in so and so's innovation center. Like Procter and Gamble is notorious for this, right? Procter and Gamble has this giant
Yep.
innovation center of stuff that they will buy and show off and then never use in production. And so like, we have flatly refused anything like that. Like our systems are only ever deployed in real production environments. We never do proof of
Love it.
concepts. Like if it's not being used 20 hours a day plus, like we're not interested in doing that project.
So at your current stage, being in 100 facilities, are you imagine you're quite, are you careful about who you deploy to or who you end up working with? Like, do you vet them for similarity or how do you choose, I guess in your scaling, how do you choose to scale? Or like what decisions are you making while scaling, I suppose?
Yeah, so we talked a little bit about what are the task types that we are comfortable with. So
Yep.
the first thing and the most important thing is to kind of validate that the task is a fit for the things that we feel like we can hit 99% uptime on. So there's a list of those things.
Is
It's,
that
it's
your
not everything on the
99% is what you're going for
99
uptime?
99.98 is our
Ah, that's so exciting.
past 12 months. Our uptime on all of our deployed systems is
Oh,
in
hell yeah.
99.85, I think is the last number that we had. So
9985.
yeah,
That's awesome.
and that's across all of our deployed systems, or the trailing 12 months number. So uh, we're tracking that religiously. That's another part where a lot of robotics companies fall short, right? With it meets performance targets, and then they have a week of downtime, right? And all of a sudden, that number goes out the door.
Yeah.
Um, so Uh, sorry, you're asking about what kinds of customers do we go after. So one, like we have to make sure that the task is a fit for what we can accomplish. Number two is we do have a kind of a specific type of ICP that we're working with today. Typically,
What's ICP?
ideal customer profile. Sorry. So our ideal customer profile today are small to medium sized manufacturers. So between 100 and 1,000 employees in the facility is a good fit for us. So we're not selling to the Fortune 50s of the world. We're selling to like all of
Hmm.
their suppliers. And so
Huh.
we have a kind of very specific reason for that. Primarily, it's about speed of decision making. But uh, all that to say, right? Like we qualify from a business perspective, we qualify from a technical perspective, and then we qualify also from an operational perspective, right? Like how many hours a day do they run their plant today? If they increase that, would it be valuable to them or not? Like we have to kind of validate all the
Oh.
business side of things too.
So you look for a good opportunity in a sense with the company.
Yeah,
So if they're already say whatever they're doing is like super efficient already and they probably wouldn't benefit that much from this, like then you don't go for them as or they wouldn't be in as high a priority a customer to deploy to
that's right.
for this kind of thing.
Yeah.
Okay. What do you think your growth curve will look like over the next like year, 2 years, 5 years? These kinds of things.
Yeah, I mean, I think we're growing, probably like 3 to 4x a year right now.
That's
So
amazing.
our goal is to kind of improve that.
Keep it doing that.
And go no,
Improve that. Hell yeah.
yeah, yeah. We want to get higher than that. I mean, I think
So
the rate of growth is increasing because right, our sales team continues to sell kind of new systems to new
yep.
customers, but one of the
Land and
areas of a
expand.
lot of growth for us exactly is in our existing customers. So the more deployed systems that we have, each of those opportunities starts to kind of triple or quadruple as they expand that solution to multiple lines and then move, upstream or downstream in that same production line to do new tasks.
That's super cool. Yeah. Yeah, the land and expand is a really powerful thing. It's interesting to me that you're going for smaller companies, like 100 to 1,000 people. And I bet you the decision making is much faster, so that's probably better for you guys.
Yeah,
Where instead of like really long sales cycles for these large companies, um, you get to ship much faster
that's
after
right.
you sell them.
The other thing
Um,
is that these smaller companies don't have innovation centers, right? So there's
aha.
no, you know,
Oh, you don't want to be pigeonholed
well,
for
no,
this kind of thing.
it's less that and more, we need people who are actively concerned with um, production outcomes, not
Ah.
innovation theater, right? And I think a lot of the bigger companies have teams of people that do innovation theater where they say, oh, let's do a Silicon Valley tour and let's have a facility where we demo all this stuff and let's kind of show off to our
Mhm.
executives. And we have an earnings call next week and we're going to talk about AI, right? Like most of our customers don't do any of that stuff, right? It's like I produced 200 parts today yesterday. I need to produce 210 parts today. Otherwise, we're out of business. And so like we're focused on customers that are much more practical in their worldview.
Oh, hell yeah. That's great. That's so funny. The innovation hubs and or the innovation facilities or whatever it is that they have.
Yeah,
So silly. But yeah, it's like they're just looking like they're being innovative, not really being that innovative.
yeah.
So if you grow 3 times this year, you'll have, well, do you think you'll have 300 deploy
Um,
facilities deployed in a year, or is it,
we may
you might
not.
have 3 times the number of robots
Yeah, I think it'll be
because
in
land and
terms of the
expand.
exactly. Yeah, we may not be in three times the number of facilities, but we should have roughly three times the number of robots.
Mhm. Let's see, looking forward, what are some of the hard challenges that you guys still are going to be going through? Like, where are the risks to you guys, I suppose?
Um, I think that there are a lot of areas where we could be doing better. In the first area is what are the kinds of tasks that we're trying to automate. And as we expand that list, the level of complexity goes up more and more, right? So like uh, each incremental task requires us to um, change everything in our process, right? Like, what are the questions that we ask up front? What are the
Hmm.
site evaluation things that need to be validated? What are the kinds of robots that are available for that task? What are the post-deployment considerations? What are the training videos that we need to create, etc. So like every new task has a bunch of work associated with it. So we're getting
Hmm.
better and faster at doing that, but like our customers expect us to be able to solve all problems. Like when we show up and we deploy one robot, uh, typically the immediate next thing that happens is, oh, like while you're here, can you do this and that and the other thing? As you know, it's not quite that simple yet, but that is one of our goals, is to be able to solve as many problems as possible for our existing customers. Um,
Huh. How do you stay focused with that? Because it's a hard thing. Because I know a lot of times when people talk to customers, those customers don't really have a good model of what robotics can do, and so they may suggest kind of outlandish things. And I suppose you probably wouldn't take on any of the like super difficult robotics things that probably are like it might even be just specific to them too. So like
yeah,
super hard and very low value.
yeah.
But how do you prioritize the things the customers may want?
Yeah. So we do like a census every once in a while, right, on all the things that people have asked us to do that we've said no to.
Oh,
And so
and
we're
then
at
you
kind
look
of
for low
level
hanging
one.
fruit in
Yeah, we
that.
say, okay, well,
What?
like if we could provide this type of case packer, uh, here are 20 customers that have already asked for it, and here are 10 more that we think we could offer
Oh,
it to. And so this is like a worthwhile opportunity for us.
cool. I really like that way of prioritize or keeping track of things for things you can expand
Yeah.
to next. This kind of thing.
Yeah, because what we're not trying
Huh.
to do is go and sell to new customer types, right? I think
Yeah,
the focus is like who are we currently successfully selling to, and what are the additional needs that they have that we haven't been able to meet. And so this is where that the kind of site scan, for example, comes in really handy, because we have a 3D LiDAR scan of every facility that we've walked. And it's not just we don't just scan that one part, right? We scan the whole facility. So we can go back in time and say, what was the what were they doing upstream of this robot, or downstream? Like we have that full scan on our in our database.
yeah, that's nice because then you don't have to get the data multiple times,
Yeah, exactly.
and that makes things a bit more efficient.
Yeah.
Okay, hell yeah. Any other points of risk to you? So improving your new process I suppose, is something. But anything else that you view as kind of like large challenges in the future?
I would say another big one is, like you mentioned earlier, like scaling up the service and maintenance footprint. That clearly has a lot of operational complexity associated with it. Right? We need to
Definitely.
have technicians across the country and outside the country at some point. We need to have spare parts available. We need to have density, in different regions to kind of support those maintenance technicians. We need to have better remote error resolution tools. So all of those things, each one has a lot of kind of operational questions associated with it. So luckily, we have a fantastic COO who's much better at kind of those operational questions than I am. And so, I think we're making great progress towards them.
Hell yeah. So I have the feeling that you have some interesting opinions about what a bunch of robotics companies are doing wrong in terms of like how they go to market and or what they're prioritizing. I mean, one that we've already said is focusing too much on getting the robot to do the thing and not enough on how to configure the robot for different customers. But what if you could reach the robotics community and kind of tell them to focus on something or do something differently? What kind of advice do you have in general for the robotics community?
I think um, one of them you nailed, right? Which is, I think we need to make sure that whoever the people who are kind of designing new robots to do new tasks are very, very focused on uh, like the the practical, immediately necessary tasks, right? I think a lot of people get obsessed with the problem. They're like, what if we had a robot that could, pick up a fabric and, do these kind of very complicated motions. And like, there's actually just not really as big of a market as they might think for that. And so like this is the challenge of engineers being engineers is like we love to solve technical problems, um, and we love to kind of make solve really hard engineering problems. But a lot of the time in robotics, like that's not where the bottleneck is, right? The bottleneck is in all the boring stuff that we talked about. Uh, I think the other thing I would say is for a lot of robotics companies, they don't think about this uptime metric that you and I talked about, right? Like we have a target around
Hmm.
99.9% uptime.
Amazing.
That is something that far too few robotics companies think about on a daily basis. So they'll ship products with all kinds of bugs, and they'll realize that like that robot goes down all the time in the field. And it's infuriating, right? But the reality is like if you don't solve all of the little mechanical things, right? Like, oh, this screw rattles and then it eventually falls out, or my suction cup kind of breaks after
Hmm.
2000 cycles, or the facility air pressure fluctuates more than I expected, and so my vacuum tool suddenly loses pressure and my system goes down every once in a while. Like these are all very, very common occurrences, and like if you want to have a robust solution that's actually useful for a manufacturer or any kind of end user, like you need to account for all that stuff. You can't come back and complain and say, well, you provided me, varying air pressure, and so my system was down. Like it just doesn't fly in a manufacturing
Hmm.
facility. Like you need to be bulletproof.
Hell yeah. And then this is a little off topic, but or maybe not exactly, not robots, but what is your read on the U.S. manufacturing system, I suppose, overall, and how can people help or get involved or like I don't know, like where are we headed and how can we make it better?
Yeah, I think that American manufacturing like world is facing like a crucible moment, right? Like this is uh, right now it's kind of do or die, right? I think American manufacturing has stagnated for the last 20 years, and it's gotten less and less and less capable. And that is a function of less and less skilled people coming into the industry, less and less labor available to do production, and kind of the constant offshoring that's been happening, right? People are kind of moving production to other regions because that's where they can, meet the performance specs that they need to. So, um, the, I think that uh, the manufacturing industry needs number one, um, like skilled people to come and join it, right? And in whatever fashion, whether that's engineers, whether that's operations people, whether that's deployment capabilities. Like there's a beauty and there's a romance to making things that I think like is just not a part of our culture that much today. And I think that that needs to change. So I'm very enthusiastic about any efforts to kind of improve that, like your podcast. Um, Number
Oh yeah.
two, I think utilization needs to be top of mind. I think that there's this fallacy that we hear a lot in American manufacturing, which is let's let other people do the low value stuff and we'll just do the high value stuff, right? Let's let other people make all the car parts and we'll make the aircraft parts. Let's let other people make all the plastic
Hmm.
parts and we'll make the high end medical devices, right? Like we only want the high margin things, right? There's this sense of superiority. Um, the problem is uh, a manufacturing industry does not exist if you can't make the low end stuff too, right? Like the people that are good at making the low
Mm.
end stuff are very likely going to be the people who are good at making the high end stuff, right? If you look at China's evolution, right, today, there you cannot make an iPhone in the U.S. no matter how much money you put towards that problem. You cannot make
Hmm.
like the most advanced chips in the US, no matter how much money you put towards the problem. It's not because we don't have great engineers, but if you don't have all the ecosystem of like the kind of the low end manufacturing, the mid end manufacturing, and the high end manufacturing, like you end up missing all of the building blocks to do that high end manufacturing. So I think it's this like logical fallacy that we've told ourselves in America, which is we're focusing on the high end, high value stuff. Like it's bullshit. Like if you can't make a cheap component, what makes you think you can make an expensive component? If you can't make a simple component, what makes you think you can make a complex component? And like the American manufacturing industry just needs to be able to support the full spectrum of things. And so, uh, I'm very enthusiastic on things that are helping kind of smaller and medium sized manufacturers because that's really where the majority of manufacturing happens in the U.S. today.
Hell yeah. Now, if our listeners and watchers take away only one thing from this episode, what do you want it to be?
I would say like the number one thing that American like people who are interested in American manufacturing need to spend a lot of time thinking about is how to increase the utilization of our existing manufacturing base. I think um, we currently have in America 300,000 plus manufacturing facilities that are churning out all kinds of products on a daily basis. Um, and the average utilization of these facilities is so low. So I would say, like for any, whether it's a kind of aspiring entrepreneur, whether it's a business owner, whether it's a manufacturer, um, to the extent that we can get more utilization from our existing base, there's so much potential there. And I think that really is the path to like the promised land, right? Of having like a really strong, robust manufacturing base that creates a world of abundance. It comes from like we already have a lot of these assets, like let's get the most out of them.
Hell yeah. Love it. All right. I think we'll end with that. This is
Awesome.
great having you.
Thanks so much for having me, Audrow.
All right. Bye, everyone. What an insightful conversation with Saman Farid from Formic. It's fascinating to see how they're revolutionizing the accessibility of robotics in American manufacturing. A few things that really stood out to me. First, their focus on increasing utilization of existing manufacturing facilities. It's eye-opening to learn that many American factories are running at far below their capacity. Second, their commitment to solving real-world problems. By deploying robots only in actual production environments and tracking usage hours, they're ensuring their technology makes a tangible impact. And finally, their emphasis on the importance of maintaining and servicing robots after deployment. It's not just about selling robots, it's about keeping them running efficiently long term. As we wrap up, I want to leave you with a question to ponder. How might increased automation and better utilization of existing facilities change the landscape of manufacturing in your local community? Thanks for listening, and I'll catch you in the next episode.